Dispatchable demand is an electricity authority initiative that enables load consumers to participate more actively in the wholesale electricity market. The electricity market is a balance of supply and demand. Dispatchable demand participants set up their load as a dispatch-capable load station, or DCLS. For every trading period, the DCLS sends dispatchable demand bids indicating the highest price they are willing to pay for electricity. The required load is the non-optimizable load. It can't be dispatched off or on by the system operator. Dispatchable demand is considered optimizable load. When the electricity price is low, the DCLS is supplied as part of the actual load. But as required load increases and the price of electricity rises above the dispatchable demand bids, the DCLS can be dispatched off, in the same way generation is dispatched on, and with the same effect on the supply-demand balance. Dispatchable demand load can either be binary or not. Bids from a binary load DCLS can be scheduled at the tranche megawatt amounts only. Bids from a DCLS that is not binary can be scheduled at any point along the line, the same as generation. This represents the price stack. It shows both generation offers and dispatchable demand bids. Remember, clearing a generation offer means bringing on more generation. Clearing a dispatchable demand bid means reducing the load at that DCLS, so they have the same effect on the supply-demand balance. We'll first consider a DCLS that is not binary and is not offering interruptible load, or IL. The marginal price is below the first dispatchable demand bid, so the load at that DCLS has been optimized on and is part of the actual load. As load and the marginal price continue to increase, the first dispatchable demand bid price is reached. At this point, the DCLS is setting the marginal price. The load will be dispatched down. It is now part of the dispatched energy resources. If required load continues to increase above the dispatchable demand bid tranche, more generation could be dispatched on, increasing the marginal price further. Occasionally, a binary load station will be marginal, and the optimal dispatch point may be within the binary tranche. Depending on the other bids and offers in the price stack, SPD will determine if there is greater benefit having the whole tranche of dispatchable demand on or off. If SPD calculates a greater benefit in keeping the binary dispatchable demand load on, it'll dispatch more generation in order to supply the whole of the binary tranche. This generation will be constrained on. If SPD calculates greater benefit in dispatching off the binary load, some generation will be dispatched down as the actual load has decreased. A dispatchable demand participant can opt to offer the same load as both dispatchable demand and interruptible load for the same trading periods. To see how this works, we'll show two price stacks, the energy price stack and the reserve price stack. In a situation where the dispatchable demand bid price is above the marginal energy price, and the interruptible load offer price is below the marginal reserve price, SPD will dispatch on the load and clear the IL, as both are beneficial to the solution. The IL cleared at a particular DCLS must be less than or equal to the load that has been dispatched on at that DCLS. In a situation where the dispatchable demand bid price is below the marginal energy price, therefore it would economically be dispatched off, but the interruptible load offer price is below the marginal reserve price, SPD must make a decision for the station from one of two options. The first option is that SPD keeps the dispatchable demand off, which means it cannot use its offered interruptible load. SPD dispatches another instantaneous reserve provider that may have offered reserve at an equal or higher price than the dispatchable demand provider offered their interruptible load. SPD has traded higher priced reserves with cheaper energy to minimize the total system cost. For the second option, SPD decides to schedule the dispatchable demand on and use its interruptible load. However, it did not require the whole dispatchable demand tranche be on, so only dispatches on the amount of load it requires for the interruptible load tranche. To meet the load, SPD dispatches on more generation, which may raise the marginal price. The DCLS will receive a constrained on payment. SPD has traded higher priced energy with cheaper reserves to minimise the total system cost. Now consider the same scenario, but this time the DCLS is a binary load. Under these conditions, SPD needs a greater incentive to access the reserves than in the previous scenario, as it must incur the additional costs of constraining on the entire binary load tranche, and therefore more generation. The greater incentive could be provided by increased energy reserve price or lower energy price. In this scenario, the reserve price has risen. The outcome of this scenario is SPD schedules on the entire load tranche to access the interruptible load offer, and schedules on generation elsewhere to supply the load tranche. The DCLS receives a constrained on payment, larger than the previous example, due to the binary load. Again, SPD has traded higher energy costs with lower reserve costs to reduce total system cost.